Here are a few things you should be mindful of when you want to apply the student t-test. Well, first, it only really works if your data is continuous. So if you have categorical data, you have to use something else, like a proportion test or chi-square. It only really works if your data is normally distributed. Your subgroup has to have the same variance, and if you have more than 2 groups, you might be in trouble as well. Here are some data on cars, and what I want to look at is see whether my car would have more horsepower if I buy it from one country or the other. So to do so, I launch the Fit Y by X platform, I put country into the X, and I put horsepower into the Y. And I just go straight ahead and launch a each per student t-test and see that indeed that it is better to buy the car from the US than buying it from other, which is a pretty broad group of countries. But yeah, so I'm done, right? No, but what about all those assumptions I talked about? Well, yeah, okay. There's actually more than 2, so maybe we should be applying actually a Tukey test, because the difference between the student t-test and the Tukey test is that while in student t, we use, you have an alpha risk of 5% every time you have a comparison, and we have 3 comparisons. I mean, there's not a big problem right now, but imagine you have 20 subgroups. All of a sudden you're running 25% risks, which is saying one of those conclusions would be wrong. So to accommodate for that, you can use a Tukey test, which has a total of a 5% risk. What does that mean? Well, it means that the risk becomes slightly wider, or the confidence intervals become slightly wider. It becomes more difficult to tell the groups apart. And we can see that in this case, we can actually not tell any of these groups statistically apart. So that was one thing. I have more than 2 groups. It's not just 2 countries. It's actually the whole world. But what about other things? We talked about, how about unequal variances? And we can see that Bartlett actually has found that these have unequal variances. So I should be using the Wilstich because it allows for the standard deviation to be not equal. Well, what if it's not even normally distributed? You haven't looked at that. Okay, so let's try and look at that. So I go into the distribution. I take horsepower by country, like so. I stack it, and by holding down Control, I will then do a continuous fit normal on all of them, like so, and go to fit at normal, still holding down Control, and do a goodness of fit. And failed, almost failed, failed. So these normal tests for normal distributions are it's like sensible. Like they don't like outliers. So for this example, you see we have one outlier there. So if I remove that, it changed from 2% to 26. So that made a huge difference. So take these with a grain of salt. Look at your data. Is it normally distributed? And if we look at the last one down here, I know that if I remove these points, it looks not normal distributed at all. You can see that it looks more like a two mixture maybe, because I don't have, definitely not a bell shape. So maybe I can't say that it's normal distributed. Okay, so I should be using non-parametric testing. Then let's do that. So I go to non-parametric, do the Wilson-Crooks-Wallace test. No idea how to say that. And then we're back to I can't tell any of these groups apart. So in 4 minutes, I have run 11 different tests. I've done 3 for testing for normal distribution. I've run 4 different tests to see whether my variances were different. And I've run also 4 different means tests. And I've tried to draw some conclusions from them. And in the process, no coding. So, but Thanks for watching, and catch you in the next one. Bye.